Okay, I have to take a picture of you because no one will believe me that I had full presentation room. So please raise your hands. Oh, thank you. You do know that you have better presentations in other rooms, like Eric Hellman's and stuff like that. Okay. Okay, then I think that we can start. Hi, my name is Zeljko. I'm an energy developer at Infinum. And today I'll be talking about an interesting topic for me. So we will take a closer look into white label systems and give some best advices, approaches in how to develop those kinds of apps. In my presentation with awesome title called Write Once and Ship Multiple Times. Okay, at first just some info about my company. So Infinum is an independent design and development agency. And we employ more than 100 people in 3 different offices in Croatia, Slovenia, and USA. Our energy team is currently consisted of 18 energy developers, and together we have worked on more than 100 projects. And okay, that's enough about Infinum. Let's go to white label systems. Okay, so just quick raise your hands. Who knows what the white label system is? Okay. Okay, for those who don't know what white label system is, so basically it's a product or service produced by one company that other companies rebrand to make it appear as if they had made it. So basically we have one application which is developed by one company. The other company buys that application from that, personalize the colors, fonts, text, and stuff like that, and then they publish it to Google Play, and it appears as if they have made it. So it's like their own application. Here is a simple example. So this is a white label system which we were working on last year. It's a white label system for theme parks in USA. So basically those 2 apps are different apps on Google Play, but they have the same source, the same code, same behavior, only colors and resources are different. So what are the advantages of white label systems? The first thing is that you provide your brand with a refined product, and the second awesome thing is that you outsource development to a trusted party, to a trusted third-party developer. So this basically means that you save time and money because you buy a product which is already battle tested in production. You can even test it before you buy it so that you know what you will be getting. You can check out the features, you can check out the navigation flows and stuff like that. So if you need, if you have a need for an application and you need to publish it on a market as soon as possible, a white label system is definitely something to look at. But also there are a lot of disadvantages, like lack of control and lack of customization. Basically, as you have outsourced the development to some other company, and that company develops that system as their own product, and you actually lose control over the development. Maybe if you invest a lot of money in that company, they will be prepared to add some features just for you, but in most cases, those companies are in charge of development. They define what will be added in the system in the next version, and so on. And also, all the apps inside white label system have unified product vision. This actually means that all the apps which are inside white label system share the same goal, share the same vision, and basically all the apps are, let's say, equal. Your app is not uniquely identified, and if you want if you want some other product vision, so maybe you see that your app should go in some other flow, that's simply not possible in white label system, unless you are a billionaire and you have enough money, then you buy that company and force them to make it. So the question is how to build white label apps, and we will try to answer it in the next couple of minutes. Up to a few years ago, the answer was quite simple. It was pure magic. Because we didn't have the necessary tools for building those kinds of systems. But basically everything changed when MVP became, let's say, a standard Android architecture, when we got Dagger, tests, blah, blah, and stuff like that. So today, the answer to that question is that you just have to carefully design the whole system component by component. Okay, so let's take a look at a few of those components. There is only one prerequisite, from my experience, when you are developing white label systems, and that is that you don't use fat clients. Okay, quick raise of hands, who knows what a fat client is? Okay. No, we're close. Okay, so fat client is server client type of architecture where most of the heavy stuff is done inside the clients. So basically all the business logic is handled in the client applications, and server is just for some, server just handles the basic requests like, I don't know, login and stuff like that, registration. The problem with fat clients is that they are not customizable on the fly. If you want to develop a new feature or disable something, enable something, change something, you actually have to release new versions. They are prone to errors and they are extremely hard to maintain in white label systems. For example, let's say that you have one application, you have one white label system, you have algorithm for something, for some, I don't know, sorting or paying bills or something like that inside it, and you identified the bug in it. And if this algorithm is baked in your application, then you will have to release new updates for each and every app inside of your white label system. And we are talking about, I don't know, 100 apps, 200 apps, 500 apps, and you'll have to force your users to update them. And that's something that's not such a trivial task. So the best thing is to move everything what is business related to the server. And that type of architecture is called thin client. And the interesting thing is that most of the systems fail on this point. I know this from my experience because in most cases when you start working on white label systems, you don't actually start it as a white label system. Basically you have an application and you bake a lot, you hard code a lot of business logic inside it. And then this application becomes a huge success and you want to make copies of that application. And if your code is hard-coded to that first application, like business logic and stuff like that, and you have to customize something for the for other applications, then you're a world in problem. Then you have a world of problems. Basically, this happened to me last year. We published application for theme parks. It was a huge success. And overnight, our client asked us that we should make 15 apps from that one source code. And we didn't think about it before that. We hard-coded everything, and it was a world of problems. It wasn't such a trivial task to refactor that. OK, let's talk at first about system architecture. So in Android, we basically have two kinds of different architectures when we develop applications. So basically, we can either use flavors or modules. And the same thing is also OK for white label systems. But you have to separate between those two architectures on the level of customization which you will offer to your customers. So in white label systems, if you want to limit the customization which you will offer to your customers, you choose flavor type of architecture. And if you want to offer advanced customizations or stuff like that, you stick with modules architecture. And you will see why that is that. OK, so for flavor architecture, pretty much everything is clear. You have main flavor and you have product flavors. For main flavor, it's always the default product, and it's used only for demo purposes, and it contains shared code. You can also make an additional flavor, which is then called like demo flavor and build from it. And in most cases, you do heavy work only in main flavor because it holds the shared code which is shared between the apps. And then for flavors, each flavor is one application inside of your white label system. It should only hold product-specific resources, classes, and stuff like that. And it should be as minimal as possible. The advantages of this type of architecture is that it's easy to maintain and develop, because in most cases you will do heavy work only in main flavor, which holds the shared code, and you would just add some customization to product flavors. Like you add new icons, or maybe copy some Java class and update the code and stuff like that. It's really easy to configure with Gradle. You just have to add new product flavor for each application. And resource and code sharing is quite trivial because everything is shared between main flavor and other flavors. The disadvantages of this type of architecture is that customization is extremely hard, and you will quickly see that the number of files, as you will be offering some customization, will exponentially increase. For example, let's say that you have a white label system, you have 100 apps, and inside of those apps, let's say that 1/3 of them have one type of UI for login screen, the other third has some different kind, and the last third have some fourth kind of UI. You will quickly see that if you want to customize things, you will have to add layout files in product flavors, because if you will stick with just one layout file in main flavor, it's extremely hard to work with views, because in most cases views are nullable. You have to check if this view is actually presented in that application, stuff like that. So if you want to provide your customers with advanced customization, then you have to switch to model architecture. So basically in that type of architecture, you have main model, and then you have product models, which have a dependency to main model. Main model works pretty much the same way as main flavor in flavor type architecture. So it contains shared code and shared resources, but it can also be minimalistic, and it can also contain only core functionalities. So basically, you can only add, I don't know, like networking layer or caching layer or stuff like that into the main model, and everything else you customize in your product flavors, product models, sorry. So product model, each model is one app. It has a dependency to main model. It uses its code, its resources, but it can customize everything for itself. The advantages of this approach is that it's really easy to customize, because as you depend on main model, you have an option. You can use something from main model or not. You can use something from main model and customize it to better suit to your needs. The second awesome thing is that apps are isolated. So basically, when you are working on one app, you have only dependency to main model, and you only care about changes which happen to that model, but not to the other apps. So basically, you can work on each app individually. And as I said, business logic can be product specific, because you can use something from main model, or you can just skip it. The disadvantages of this type of architecture is that it's extremely hard to maintain, and you quickly lose focus. With this, I mean that as you're offering an advanced customization to your customers, your apps can quickly diverge. So basically, they're not in a white label systems anymore. They are individual app who just share some functionalities like, I don't know, networking layer or stuff like that. And that's something that you want to avoid. Or if you see that you are losing focus, you just isolate those apps and remove it from your white label systems. Okay, let's talk about customizing app behavior. So basically, for shared code, it's pretty much trivial. You just use the same class in all your apps. But if you want to customize something, that's the fun part. So, and complicated part. So obviously, the most the simplest thing is using build config file for customizing the constant values between the apps. So basically, if you have flavor type architecture, you define constants in your Gradle file, change the values per product, and then use the constant values in your app. For example, let's say that we have 2 apps in our Whitelabel system. They use same constants, Google Analytics ID, API URL, and URL schema, but the values are different. So basically, you can see that API URL changes between those 2 apps and Analytics ID and stuff like that. And then in the code, you don't use hard-coded values or constant values or stuff like that. You use the code from build config file, constants from build config file. And the awesome thing is that build config is generated every time when Gradle syncs. So basically, all of the changes are automatically deployed to your apps. Also, Gradle is an awesome tool to basically customize everything. You can customize resources, you can customize configuration and stuff like that. This is just a simple example how to customize resources. So basically, in Gradle file, we can say that you add me string called search authority, which will be a combination of application ID and some constant value. And application ID actually changes between apps. So in Gradle file, you can easily define different values for applications just by defining that you want to add some resource string. If you want to be more flexible, or if you want to handle some more complicated cases, then configuration file is a way to go. So configuration file can be either locally cached in your application, or it can be obtained from the API when your application starts, or you can use Firebase remote config for that. The thing is that configuration files are more flexible because you actually can write Java code and customize everything. And there is only one rule when you are using configuration files, and that is that you use descriptive method naming. More about this later. With configuration files, we can easily customize different applications inside of our system on the fly. So basically, with changing values in configuration files, we can enable or disable features per apps. We can customize data flow, or we can customize screen flow. Let's take a look at a simple example. So let's say that we have a locally cached configuration file. So we define an app configuration interface, and we define 2 methods with which we can customize our application behavior. So the first one will provide us with information if social login is enabled in our app, and the second one will return the list of menu items which are used in navigation menu for a logged in user. And then we simply provide the implementation of this configuration in each of our products. So basically, we define that our white application will have one implementation, so it will have its own set of menu items, and social login will be enabled if this cause is set to true. For blue configuration, we can return something else. For red configuration, we can return something third. And then you just call the interface inside of your application. So basically, I know you will, in your presenters, you will write app config is social login enabled, and the implementation of that configuration will be provided with Dagger. So basically, then you can change it on the fly. For descriptive method naming, so method names should be descriptive and they should not contain product names. The thing is that you want to ask yourself if a feature is enabled. Get me the data for this screen and stuff like that. If you ask yourself, am I in product A, or am I in product B, or am I in product C, then I know you use this flow. And if I'm in product D, H, and F, then use some other flow. This is a recipe for disaster, because as your Whitelabel system will quickly increase, then you will have to add methods for each new application throughout your code. So this is really wrong, and if you're using configuration file, just use descriptive method naming. We've already talked about this a little bit with configuration files. When you are working in a white label systems, you have to start programming to interfaces. So basically, you extract your functionalities to interfaces. Each time when you integrate with an external dependency, you extract that to an interface, and then you can provide a default or product-specific implementation of that interface, because that actually provides you with advanced level of customization. So, for example, let's say that we define an interface which is called image loader, which will be used for displaying images in our image views. Every time when we want to display an image, we will just call this interface image loader.display image, and we don't care how this image will be displayed, which caching library will be used, which async image retrieval library will be used. We just want to call that method, and we don't, at this point, we don't care about how this will work. And then you provide implementation of those interfaces either in configuration files, either in Dagger models, and stuff like that. And these implementations are then specific either by your product, or you can provide default implementation. So let's say, for example, that we want to provide implementation of that interface before, and based on some value, which is obtained from the configuration file, this image loader type, we can switch easily between Glide image loader, which will load those images using Glide library, and Picasso. And this is an awesome way to customize behavior, because in most cases, when you will be working in white label systems, you will quickly find out that different customers have different needs. For example, maybe if you're using Glide, it has a license type which is not suitable for your customer, and you have to switch to something else. Maybe they want to use their own product and stuff like that. So basically, if you extract it to an interface, it provides you with easy way to customize the behavior. Another awesome thing is that you can include external dependencies only for specific product types with a specific version. So basically, you can say that if we are in flavor type architecture, that you only compile Glide version 3.6.1 for white product, and for blue product, you compile some older version. And this is an awesome tool, an awesome hack. We used this heavily last year. As I said, I was working that theme park application, and we used a library which was produced by some other company for geolocation inside the park. And they actually provided us with different versions of that library for different parks. So basically, you compiled version, I don't know, 1.4.0 for 10 types of applications. For other 10, you compiled different version and stuff like that. Moving on. The last thing you have to do is that you should start grouping functionalities into features. So this means that every part of your application has to be grouped in some kind of a feature. By using this approach, you can easily enable or disable features per product type, and they can be customized. So let's say that in my UI layer, I have 7 different features, and everything what's needed for one feature is inside that package. So basically, I have a login feature in my application. On UI level, I have 4 different things for that. I have an activity, MVP file, presenter, and dependency injection. And now I know if I have to change something or customize something, that everything what's specific for that feature is inside of that package. What's even more awesome is that you can label your features as open or closed. If they are open, then they are available for customization. If they are closed, then you have to use the default implementation. And this is great if you have some core functionalities which you don't want to customize. Like, let's say that I have a networking layer in my main model, which uses OKHTTP and retrofit, and I don't want that I can use some other type of networking layer in my other applications. So with that, you can just say that this feature is closed. So basically, you just say that these classes are final, and then you cannot overwrite or extend them. OK, so enough talking. Let's take a look at some examples. So let's say that OK, let's start with the simplest one. Let's say that we have a white label system. We have one application, one shared code, and we want to build 10 apps from them for that system. And we just want to customize colors and strings. For that, we just use flavor-specific architecture. So all the default resources and values are in main flavor. Everything what we want to customize is inside of those product flavors. Obviously, we need to use the same key for those values. So basically, if you are customizing constant value or using different icons, you just have to keep the name. The key has to be the same. OK, the more complicated example is that let's say that we have a system which has 10 applications, and we want to customize business logic for each of those apps. For that, we can use MVP architecture. Presenters are interfaces, and we provide presenter implementations per product. So basically, you extract the business logic to a presenter. You expose the API for that presenter with some interface, and then you provide implementation of this interface per product type, and you can easily change the business logic, and you just use Dagger for injecting the correct implementation. The main drawback of this approach is that dependency injection has to be handled per product, so there's no default option. And let's go one step further. Let's say that we have a system where we have 100 applications, and 99 applications behave on the same way, so they have some default implementation. But just for one, we would like to provide a different type of implementation. So we would like to customize the behavior. For that, we will use a mix of interfaces, features, and configuration files. And then we can provide either default configuration, default implementation of that feature, or we can provide custom configuration. I know that this sounds a little bit complicated, so let's take a look at a simple example. So let's say that we have a feature inside of our system. We want to create a trip. So basically, you have a screen where you input either the location name or location coordinates, and you want to navigate your user to that screen. Also, we want to use a default navigation flow, and it has to be customized only for one or two products. So basically, when user clicks on, I don't know, create a trip button, default implementation will be open screen A, fill all the necessary fields, and then we will open a second activity in our application, which will show the map and we will show you the path. And we want to customize that behavior just for one application or two, that it opens a different type of application, a different type of screen for navigating the user, maybe even navigate him to Google Maps or stuff like that. OK, so at first, we will define a navigation interface, which will be used for navigating throughout our app. So basically, every time when you want to start create trip feature, you will call create trip method on the navigation interface. So this is just an interface which defines what is the possible navigation inside of our app. Then we define the second interface, which actually defines what is the type of behavior for that navigation. And we also define the same method. So as you can see here, we have create trip, and in navigation behavior, we have start create trip screen. It has some input parameters and stuff like that. Then we provide the default implementation of our navigation interface, and in this case, we just delegate the navigation to navigation behavior. So basically, each time when you call create trip method, it will be delegated to navigation behavior interface. And then the awesome part starts, because we can customize the navigation behavior interface by providing different implementations. So let's say that in our default navigation behavior implementation, we will start create trip activity with some input parameters and with the same request code which was forwarded to navigation interface. But then we define a different type of navigation behavior for our second application, which will use plan trip activity. So basically, by changing the implementations of navigation behavior and by providing those implementations with Dagger in your products, you're customizing the flow where you lead your user in the application. We can also provide a different type of navigation behavior. Let's say we can provide a Google Maps navigation behavior, which will navigate the user to Google Maps to use it for navigation. And then just by providing different implementations, we can customize the navigation flow. But the thing is that if you let your customers to customize everything, you will quickly get in a situation where you will have a request from your client that you implement the same functionality as in 100 other apps. It has to be different, but still the same. You know, like I want to customize everything. I need to have my own implementation of business logic, my own implementation of navigation flow, blah, 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 but I still want to use your white label system. And that's the time where we have to sit and say to the customer, no, we cannot provide that kind of customization, or we can provide it, but we have to extract the application outside the white label system and let it live on its own. Because in those cases, product vision has changed. Basically, you have an application which is a huge success, and if you customize your whole white label system just for that application, that's not what white label systems are. So basically, if a product vision has changed just for one application, you have to remove it from the system. And how to achieve that? Well, in most cases, the flow is pretty much simple. So we start with flavor-specific architecture, where everything is, let's say, tightly coupled between default implementation and custom implementations. Then we refactor the architecture to modular one. So basically, we just depend on some main model. And through the time, we remove the dependencies to main models. So basically, I know we will remove navigation handling, we will remove network layer, caching layer, stuff like that. And when we remove the last dependency, that's the time when this application can start living on its own, and you can safely remove it from your white label system. I got a lot of questions last time when I did this presentation. Why can we just leave some core functionalities which are shared, but everything else we just customize? That is a bad thing to do, because if you want to extract your system, you just have to do it the right way so that you don't have any shared dependencies, because as product vision has changed, it is possible that developers of white label systems will change something in that core model which will break your implementation or which will not work okay for you or stuff like that. So let's say that product vision for one application has changed. We have removed everything but, let's say, caching layer, because white label system has that beautiful, fully working caching layer, and we don't want to do this by our own. But let's say that they have decided to switch between caching mechanisms. So basically, I know they wanted to start using RHEL or something like that, and that's not working for you. So you have to remove all the dependencies provided by yourself, and then you are safely, then you can safely say that this application can live on its own. Okay, so to round up everything that I was talking today, if you want to use white label systems, please use thin clients. Fat clients are a recipe for disaster. Plan your architecture, plan it in advance, and have architectural reviews of your systems at least twice a month, so that you can, if something goes wrong or if your system is not working correctly, then you can detect those problems in advance, and you know what to do. You can fix it, you can refactor it, stuff like that. Offer limited customization to your users. In most cases, I would strongly advise that you just offer customizations for colors and resources and text and stuff like that. If you have to offer some more advanced customization, you can use those approaches which I've talked before, but don't offer too advanced or too much customization, because if you customize everything, then it's the time this application leaves the system. And that's it. That's everything that I want to talk about today.